Hello, and welcome to our joint webinar hosted by Rico and Tiger Coatings. We're all here today to talk about thermoset powder and printing. I'm Mark Dickin, the Engineering Manager for Rico 3D. I'm pleased to introduce my colleague Enrico and the guys from Tiger Coatings, Barris and Thomas. I'm extremely excited to introduce this webinar today. We're going to talk to you about a truly unique, disruptive innovation in the SLS space, a thermoset powder that can be customized to your application, including a V0 flammability rating. To quickly run through what we're going to cover today, we'll give an overview of Rico and Tiger Coatings, a comparison between thermoset and thermoplastic materials and how they behave, the key advantages of the material, and then to finish with a Q&A session at the end. If you do have any questions as we progress through the presentation, please feel free to add these into the chat. So, a little bit about Rico. We are a large Japanese company with headquarters in Tokyo. We have a global presence as we operate in more than 200 countries and have around 97,000 employees. The company was founded in 1936, originally to manufacture and sell sensitized paper. We have more than 80 years of experience in manufacturing, and the foundation of the company has very much evolved. Today, our mission is to help businesses transform their processes to become more efficient, productive, and sustainable by empowering their digital workplaces and digital operations. Innovation and quality are the heart of what we do, and as you can see, we hold more than 50,000 patents worldwide, and our operations comply with many quality standards. As an organization, we all work to the same values, which bind us together as one global family. We have a long history of innovation. Most people know Rico for our office printers. However, our product portfolio and capabilities extend much further than that. We do have a wide range of commercial and industrial printers, as well as inkjet heads. But as you can see from this slide, we have a diverse portfolio that goes beyond printing, from cameras to data management solutions, from interactive whiteboards to bioprinting technology. Of course, last but not least, 3D printing sits in our industrial line of business. Initially, we entered this market by supplying our inkjet heads to 3D printer manufacturers, but also by using the technology within our group on our own products and manufacturing operations. In 2019, we launched a range of additive manufacturing services, making 3D printing accessible and taking an honest approach to its role as a true manufacturing tool. Rico 3D is located at our showcase factory based in Telford in the centre of the UK. We have an engineering function within group supporting our core business operations at our marketplace factory. At Rico in Telford, we have our own independent businesses such as our Inkjet Technology Centre, toner filling, injection moulding, 2D print centre, and our additive manufacturing centre of excellence. At this factory, we have a history of customer centricity and co-creation, developing solutions with customers. Before the COVID pandemic, we welcomed hundreds of visitors to our site on an annual basis. Our core business operation is the manufacture of toner products. Toner is, of course, a fine powder, which synergies with additive manufacturing. So, we are a manufacturer at heart. This is where our specialities lie, and we are geared up for mass production. I could probably fill an entire webinar slot talking around this slide. However, I'll quickly summarize this. The information shown on this slide essentially shows our value proposition. We are very different from your traditional service bureau, which is intentional, by the way. From our unique selection of SLS and FDM materials, tailored engineering services to meet the customer needs, to full mass production, utilizing the correct industrial manufacturing technology, we provide the highest quality solution to our customers. We also have an array of certifications to give credibility to our claims. We have also just received the medical standard ISO 13485 for the manufacture of medical devices. I will now hand you over to Thomas from Tiger Coatings.
Thank you, Mark, for the introduction. My name is Thomas Wagner, and I'm proud to represent Tiger Coatings during this webinar. Tiger is a family-owned company with headquarters in Austria. We have 90 years of history and 8 production plants around the world. 3 of them are in China, 1 in Vietnam, 1 in Canada, 1 in the United States, and 1 in Mexico. Out of this, we have 40 affiliates and warehouses all around the world to serve our customers. With our 3 R&D centers, 1 in Wels, Austria, in our headquarters, 1 in St. Charles, Illinois, and 1 in Taichung, China, we try to support our customers all around the world as good as possible. Dealing with the automotive industry, Tiger is ISO 9001 certified and, of course, IATF 16949 certified. Next, please. Tiger is out on the market already since the early 1930s with our wet lock products and was turning the business somewhere in the late 1916 into powder coating factory. Since year 2000, we deeply investigated in digitalization, and one of our major goals was to add digital inks and powder to our portfolio, especially for industrial use. And since a couple of years, Tiger was as well in the field of producing 3D printing materials based on our Thermoset experience. Next, please. Looking at Tiger's journey and Tiger product offer, this is a lot of interaction between the businesses we have started, and the business fields can be combined as, for example, if you print a part with our digital 3D set material, you can also use our powder coatings for dry lock powder coatings to get the final finish of the part and coat the part with this powder coatings, or even you will bring a digital tattoo, for example, onto it. Next, please. This is a slide which represents the philosophy of how we work together as Rico and Tiger. And the ultimate goal of these both companies is to reach the best solution for the part of our customer. And for this, several fields are important to reach this goal. And this is, on the one hand, the printer, as of course the part design, it is the processing, but it's as well the printing parameters and of course the material design. And this is what we want to do as Tiger and Rico, to work as close as possible together with you as our customers to bring the best out of these technologies and to bring a better functionality and solution to our customers. Next, please. We see a lot of pain points in this 3D printing, and we are confronted with this. And one of this is, of course, the cost for the final parts, and we're working together on this to get good cost in the part, but as well the availability of materials. But we believe that especially to small production or small lot productions, 3D printing can be a good solution. Indeed, if you think about spare part production, there is a risk of putting away old, outdated parts, which is a risk and the financial side of your business as well. Next, please. Therefore, we want to invite you as well to get your opinion about the pain points you are serving. And please put your vote on it, and we will come back on this at the end of the presentation. Next, please. Yeah, with this, I want to hand over to Paris Kainak.
So thank you very much, Thomas and Marco, also for the introduction. So to give you a short interview, what means Thermoset and what are the differences between Thermoset and thermoplastics, I would like to bring it closer to you. Thermoset materials are systems which are reactive resins, which can get to react under UV light or under heat beam. In that case, you got in touch maybe with Thermoset materials with SLA printing technology. What we did as Tiger, we are bringing the Thermoset materials which are commonly used in SLA. Also, we are making it possible for SLS technology. What happens during the printing process based on this laser which is used in the SLS printing technology? The material is not getting directly melted; it's getting started to react with each other and with the other materials which are getting in touch with the laser. And based on this cross-linking and reacting with each other, we can reach higher thermal stabilities compared to thermoplastics. Just one example, if you heat up a Thermoset material, which is completely cured, if you heat up to 200 degrees compared to PA12, polymer 12 will start to melt. But the Thermoset material, which we are offering to you, will just get soft. It will get like an elastomer material, but it will not start to melt. The design which you printed in the printer will not change. And this gives you also the opportunity, if the design or your CAD file wasn't perfect and you would like to adjust the angle of the part and to make it more easy to fit to the application field, you can just heat the parts and adjust the angle or the length of the material. And this gives also the opportunity to be flexible in design also. And if you look to thermoplastic materials, the most thermoplastic materials are crystalline systems. So that means during the printing and cool down, you have a huge shrinkage. So if you look to PA12, we are nearly at 4%. That means directly with shrinkage and warpage of the materials. Our Thermoset materials have a shrinkage below 1% during the printing process. This is one of big advantages of the Thermoset materials, because it enables you to print huge parts. Just one example, 20 by 20 centimeters, 10 centimeter high plates. Nobody needs this kind of material parts, but it's able to print with shrinkage below 0.5% in the printer. And because of the cross-linking of the Thermoset materials, we are reaching also high outstanding dielectric strengths. And the chemical resistance of Thermoset materials are in the polymer sector really common and used. That's why also for electrical application, because the Thermoset materials are not absorbing water-based systems or any solvents or liquid systems. There are, of course, also advantages of thermoplastic materials. We don't want to say thermoplastic materials are worse, just use Thermoset materials. But in case of application fields, Thermoset materials brings you advantages which you can't have currently with the 3D printing materials out of the SLS. And if you look also the surface finish of the Thermoset materials, it compared to the thermoplastics, it is an excellent surface finish. And in the next slide, what we can say is there are no commercial Thermoset powders for SLS 3D printing available right now. So we are the first ones who introduced this material to the market together with Rico last year during the Formnext 2019. And we believe with this excellent thermal and mechanical properties and high chemical properties of our materials and the high dimensional stability, will expand the application for a field of SLS 3D printing. And I would like to hand over to Enrico, who will bring you the key advantages of Thermoset materials for you closer.
Thank you very much, Boris, for the introduction, and okay, thank you very much to everyone for joining this this webinar. So yeah, let's dive a little bit more into the main properties and advantages of this class of material, starting from the mechanical properties. So in terms of mechanical properties, this material have a very good abrasion resistance, and also a very good creep resistance, which means that when they are submitted to mechanical stresses, even for a long period of time, they are able to maintain their initial shape. Another advantage compared to most of the thermoplastic material available for SLS is the possibility to achieve isotropic mechanical properties, which means that the mechanical properties of the material are independent of the printing orientation. And this kind of performance is achieved thanks to the chemical cross-linking happening during the printing process, and it is enhanced by the post-processing step required to fully cure the materials. Also, these properties can be easily adjusted and customized by playing on the material formulation, but also on the printing parameters, so we can really fine-tune and tailor those properties and make them suitable for specific application. So thanks to these properties, this material can be used for very demanding application in several sectors, such as automotive or railway, aerospace, as well for the electrical industry. And when we look at electrical application, an important feature of this material is their very good insulating properties combined with high dielectric strength, which also with the fact that they can withstand sudden increase of temperature without losing their shape, makes this material a very good candidate for this type of application. And as Boris was mentioning before, water uptake, which again is an issue we can see with nylon material, for example, is very minimal with Thermoset. So again, this is another benefit for electrical application. And on top of that, this material can also be formulated with flame retardant properties. And sometimes I really think that seeing is believing. So as you can see on the video on this slide, which compare a Thermoset flame retardant material in the middle with two thermoplastic material on the side. The Thermoset, when they are exposed to fire or to a source of heat, they show this self-extinguished behavior. You can see there is no polymer melt dropping, and they also generate very low smoke. So we have tested the material according to the UL 94 testing, and it is possible to achieve V0 flammability rate for a minimum thickness of 1.2 millimeter. And also the fact that the material, when exposed to a source of heat, can keep their shape at this high temperature is due to the fact, as I mentioned before, that during the printing process we really create a three-dimensional network of chemical bonds between the polymer chains of the material. And basically what we are doing here during the printing process with this type of material is that we are using the laser in the printer to create a chemical reaction between the polymer chain rather than melting the material as it happens with thermoplastic material. So also just to give you some figures for comparison in terms of thermal performance of this material, their heat deflection temperature A could be up to 110 degrees, which is higher compared to the heat deflection temperature in the same condition for a typical nylon 12, even a flame retardant nylon 12 material, which has generally an HDT of around 80-84 degrees. And also, this material have also a very low coefficient of thermal expansion, which also contribute to the high dimensional stability. Now hand over back to Baris, that will guide you through the final slides of the presentation.
Thank you very much, Enrico. If you look to the requirements of the customers, so there's never one polymer or one product which will solve any requirements and every requirements which is needed. So with a background of 50 years in knowledge in thermoset materials, Tiger is able to adjust the materials to your needs. Starting with the mechanical properties, we can adjust the resin formulation of us so far that we can adjust the mechanical properties starting from the elongation up to the strength of the materials. And also in case of thermal properties, we can adjust also the thermal properties in using different kind of filler systems, because we can adjust the formulation really easy and really fast in using of high thermoconductive fillers, or to improve the thermal conductivity, or if you don't want to have a thermal conductivity, we can use also high insulating filler systems. And also this is possible for electrical properties. If someone needs electrical conductive systems, we can use and adjust the material properties to that. And in the last case, also the chemical properties, we can adjust to your needs. The reason why we are offering this customized products is also because we are trying to give you the best solution together with Rico, and can adjust the formulation of the powder to your needs. And if we would summarize the material properties in a small nutshell, as also Enrico mentioned, the advantages, the high super insulating capability of thermoset materials are well known. That's why most of the electrical application, like one example, hair dryers are made of thermoset materials because of the high thermal stability and insulating properties. And due to the cross-linking which we are achieving during the printing process, and we can reach high mechanical properties, and the reason why thermoset materials are used also in aerospace or in other industries is also because of the high enhanced mechanical properties. This cross-linking brings also the advantage of the high temperature performance. And one of our key and also unique selling points for our material is also the adjustable flame retardancy. The materials are not dripping during the burning step, and we can adjust it up to UL94V0. One point which we would like to highlight is also the fast production and low printing temperatures. What means low printing temperatures? We are printing below 70 degrees. Our printing temperature, printing window is between 64 degrees to 68 degrees, and we can print our materials in that range. And we are using the same SLS printer with an open platform. So materials, our materials can be used in any 3D printer with an open platform. And as I mentioned already, we can customize the products to your needs. And the advantage of the low printing temperatures gives also you the opportunity to use economic printer systems. And as we also told already, the surface finish of our materials is really easy done, because we can adjust the chemistry of our printed parts to the chemistry of the coatings, and like in our case to the powder coatings, and the attachment between the coating and the printed part is enhanced because of the similar chemistry, and you can reach a high level of surface finish. And based on this 3D cross-linking during the printing process, we have the advantage also that you can achieve isotropic properties in X, Y, Z direction. And the other important point is also it doesn't matter where you print the part, on the left side of the printer bed, on the right side, back or forward. In the end, because of the low printing temperatures which we are using, you don't have this problem with the thermal control in the printer like in using pH6 or pH12 materials, which is commonly used. And Thermoset materials have an excellent chemical stability, which we already explained also. And one key point is also the hybridization of our materials. That means you can directly use endless fibers like carbon fibers or glass fibers to improve the mechanical properties of the parts and combine these systems, or you can also use a directly metal part or driller that you can directly drill the parts because of the high mechanical properties. So it's not creeping, it's not changing the whole parts system, and it's not getting melted anyway. So hybridization is really easy done with our materials. And coming up to the last point, dimension stability. It enables you, because of the low shrinkage of the materials, because we are amorph systems, it enables you to print huge parts. And if we look what is possible with our materials, and we are able to produce the powder itself in different colors, starting from red, blue, white, or any different colors which you need. And as I mentioned, because of the low shrinkage, you can print really large scale parts. Over 20 by 20 centimeters. Of course, it depends what kind of a printer you have or what kind of parts you need. But this is possible without warpage and shrinkage. And the advantage is also you can stick the parts really easy to each other and glue them without any issues, because this gives a huge advantage of the Thermoset materials also. And if you look to the printed parts which we produce already, together with also Rico, and we can print parts with high resolution. And we can customize our products really well to your needs. And so I can introduce you the 3 materials which we want to launch or did launch already. The first one is the high performance polymer, which we showed also during the Formnext together with Rico in 2019 during the Formnext. So it has a high dimensional stability and accuracy, high tensor modulus with a HDT value of 65 degrees. And the second material of us is the top performance polymer with a high mechanical properties and high thermal properties. We have a HDT A values over 120 degrees, and we can adjust the HDT value to your needs up to 140, 150 degrees. And the last material of us, which I would like to highlight again, is the premium performance polymer with a high outstanding flame retardant properties, which can be used in different application fields like in aerospace, in rail, and also in automobile industry. It has a HDT value over 100 degrees, as already Enrico mentioned also. And I would like to thank you and give over to Mark.
Thank you, Boris. So we've recently launched a new website with live online quoting. The option to select the Thermoset material is now live. The technical data sheet is also located within the resources section on our website. I would encourage people that are interested in the material to reach out via the Speak to an Expert contact. As you've hopefully seen from today's webinar, we can totally customize the material, so we'd like to make that journey together with you. It's also now time for us to move on to the Q&A section. I'd just like to thank all participants and the team at Tiger for making this time for the webinar. I think it's been a fantastic overview of how a Thermoset powder can be used in SLS technology. I hope it's got many of you thinking. Right then, guys, on to the Q&A. So we have the results of the poll. We have a quite interesting split there, and it's showing that over half of you feel that some of your pain points are around the cost of hardware investment. I guess this isn't surprising in the current climate, and this is where Rico can really help you by utilizing our print service to cater for your needs. This is also closely followed by a high number of you selecting the performance of materials as a pain point, or maybe a restrictor of the technology. I think this is the beauty of this material from Tiger. We can adjust the mechanical properties, as you've heard, within reason, of course, to the desired application. So, you know, really good feedback. Thank you for that. So onto the questions now. So we've been asked quite a few very interesting questions, and I'm going to put this to the panel. So SLS of Thermoset, is it 100% isotropic or orthotropic to a degree? I think Baris, I think you'll be the man to answer that.
It is 100% isotropic system which is printed, and because of the completely different behavior of the viscosity, also compared it to thermoplastic materials, which I can also answer. Another questions will come up based on the porosity. So if you look to the printed parts inside, you will never see in which direction you printed the parts, and you will not see any porosity. And that's why it's also like a wall. If you put some liquids or anything inside, you will never have liquids which is getting out of the printed part. And it is like a molded. It looks like a molded part in the end.
Yeah, good answer, I think there, Baris. What about, we have another one here. Does the material become gelled during the print process? Is the chemistry so fast that only a short exposure to a laser is enough to drive the thermoset to gelation?
This is where I can be really proud to be part of the company. This is a knowledge which we have over 50 years. So we can adjust the thermoset materials so fast that we can reach a level of curing step which is not anymore in gel situation. And maybe we have to mention also the parts are getting also post-cured. So the second step, so we are curing the part completely then in an oven for 45 minutes at high temperatures like 180 degrees, that you can get a fully cured part if the laser is not completely curing the parts.
I think you mentioned, you covered this in the presentation, Baris, but just to touch on this point again, what is the highest TG printable material offered?
Highest TG printable material is currently 145 degrees. I mean, the TG is something different. I meant what I mean with 145 degrees is the HTTA value with 1.8 megapascal pressure on it. And TGs which we can reach, glass transition temperatures are over 150 degrees.
And we're just going to save your voice now, Baris. I'm going to ask Enrico. Enrico, so how is can we reuse the thermoset powder in the same way as thermoplastics?
Yeah, we can reuse the powder, so we are not like, we don't need to print every time with just virgin material. Again, the guys at Tiger, they've done a very good work to work on the recyclability of the powder. So depending on the material, we can potentially go up to 40% recyclability, and obviously we need to be also careful when we store the powders, because these are, compared to thermoplastic, thermoset are a reactive material, so we need to be careful, you know, not to expose them to high temperature condition, because that will have also potential risk of degrading the powder before actually printing. So
okay, thank you, Enrico. And another one here, do you routinely compound thermosetting resins using an extruder? Do you offer this service as a toll service? Maybe for you, Baris.
Using it for extrusion?
Yeah, well, the question is, do you routinely compound thermosetting resins using an extruder? Do you offer this service as a toll service?
We don't offer that service because we are actually material producer and developer. So in that case, I think the best solution for that is Rico, who can support you in case of producing parts. Or this would be my recommendation.
Great. Any information about the powder size, distribution, and particle geometry?
Yeah, the powder is actually, we are working really close with you guys, with Rico together, and the powder is actually available. And Rico has huge experience on that, also how to treat our powder. So anytime, I think you guys are always available and open for discussions with the customers to start and to print parts for them.
And again, I think this one's here for Enrico. What is the minimum thickness that can be made from part printing? I think we can both answer that, can't we, Enrico?
Yeah, if you want to answer it, save my voice, I can answer.
Save your voice. No, I think it's very, very similar to thermoplastic material there to what we know with standard PA12, but some of this will depend on the machine limit on the machine itself. Sorry, Enrico.
Yeah, and to add on top of that, I think it's this material. Although we have now some good knowledge of printing, obviously, the more we will print customer part, and the more we also learn and sort of be able to really identify the full limitation of the process. But yeah, I agree with you. We got experience with printing parts with minimal feature of 1 millimeter, this kind of range, and there is no problem with that.
And then is an inert atmosphere needed during printing?
Sorry?
An inert atmosphere needed during printing?
By default, with our printer, we generally use a nitrogen atmosphere. So and I think this is the same for the guys at Tiger. Not sure if they have tested without an inert atmosphere on their side.
The good thing is we tested it once, and it works also without the inert gas. But most of the printed technologies which are currently in the market, they don't run without nitrogen because of the safety regulations of the ATEX situation in Europe. And they are not allowed to run without nitrogen. But our system is also working in desktop machines, which we tested with CO2 laser without nitrogen atmosphere. So it was an atmospheric atmosphere, and we could print without any issues because of the low temperatures which we are using, like at 65 degrees. There's not a degradation of the powder with oxygen in the air. The only thing which we have to think about is if you have humidity in the chamber, the biggest challenge is always the laser power which you want to have on the powder. This is decreasing because the humidity is absorbing always infrared. And this is, if you use infrared lamps or different kind of laser systems, this will reduce the laser power.
Thank you, Boris. Another one has come in here, which I think I'll take. Does the Thermoset powder need to be printed just on a Rico machine? The answer to that is no. At Rico, we obviously have our own Rico printers, but we also have printers, SLS printers from other manufacturers, and we have qualified this powder on both the Rico machine and third party. So no, it is not just for the Rico printer. So hopefully that'll answer that. And then another question here just come in is sorry, let me just read this. So it says no fume to expect during the melting curing process. which affect the efficiency of the process? And how long does the powder can survive in the heated powder bed without affecting the quality of the powder? Probably to you, Baris, for that.
Yeah. So our typical printing process times which we are testing is always nearly 30 hours. And during that time, we didn't see any issues with the mirror or any laser problems. You guys are always highly invited and welcome to our 3D printing center to see also our printers in-house, which we are using nearly 2 years just with Thermoset materials. And most of the technicians from the printer producer are always surprised that we are using these machines daily. And it looks like it's a completely new machine. So you don't have any problems with our material with over 2 years. So it's not like if you don't heat up to 160 degrees, 170 degrees, and at that temperature range, 65, 70 degrees, it's also not, let's say, attacking this temperature, it's also attacking the printer normally. And we use 65 degrees, and it's also really good for the print itself. And if you look to the lifetime of the laser, we are without any issues, 2.5 years, we have the printer and nothing changed. So it's not hurting the printer.
Baris, again, for the shelf life of the powder, would manufacture?
We tested the powder over 100 hours, I think 120 hours, and we didn't see any changes. So it's compared to the existing materials. So this was 100% of the same powder, so over 120 degrees. So you don't see any differences in the quality.
And then, is there any plans for an ESD safe FR material?
ESD.
ESD, yeah.
Okay. I don't know what does it means actually, but what I can tell is our flame retardant material is free of halogen flame retardant materials, so we don't use any chlorine or fluorine systems. And maybe this answer helps.
Okay. And then we've been asked another here about, is it faster to print with Thermoset compared with thermoplastics like P11? I think the short answer to that is yes, because of the low temperatures that we process at, and also we don't have to go through a long cooling cycle there. You know, the material, as soon as as we've finished printing, the material, the cake can be removed directly from the machine, and the machine started again. So yes, the process time is significantly shorter, and obviously which will increase your utilization ratio of your machines. Another one, is there a plan for a material with higher elongation?
Yeah, there's a material. We have already material with a higher elongation. The highest elongation which we can reach right now is 9% of elongation with our materials. And there's a limitation on that on thermosets, because if you go higher with the elongation, of course you will lose with the other mechanical properties, and like you will come up to the same A modulus or strengths like the thermoplastics, and you have to always to compare what you want in the end. You want to, if you want to elongation, of course you will lose on stiffness and also on A modulus. But it's possible we can increase it up to 10%, and it depends, of course, on the thermal properties also. With increasing the elongation, of course, the thermal stability is also decreasing.
Okay.
You have to. There's everything is on a, let's say, equilibrium, and if you change something, the other part will also change.
Baris, just to go back to that question about ESD. ESD is electrostatic discharge safe. Are you familiar?
Actually, with the flame retardancy, I don't know how to combine it right now. I'm really sorry for that. Because electrical discharging, so we can adjust, let's say, the electrical conductivity of the material. So we can use fillers which are electrical conductive to avoid electrical discharging of the polymers. And this is actually which I have to look for that. And if someone wants to discuss about that and clear more, please just contact me.
Okay.
And we can have a talk on that personally.
Okay, thank you, Boris. I think in the interest of time, we need to draw today's webinar to a close. I'd just like to thank everybody very much for their time today. If there are any questions that we've not been able to cover today, we'll make sure we'll follow up and would welcome you to get in touch with the team if you think of anything afterwards or would like to discuss a specific project. Thank you for your time and keep safe.